Hello everybody, I'm back with you with the Numericals of Module 1. With my last video lecture, we have completed all the concepts, topics which are given for you in your first module. So, I hope you all have understood the concepts, and I also hope that you all are able to recall the formulas and the concepts and the phenomenon and the definitions, everything you should be able to recall now. Okay, if that's the case, then you can enjoy this video lecture. Please carry with you a notebook, a pen and a calculator so that you can follow along with me and calculate the numericals. Let's go ahead. Calculate the velocity and kinetic energy of an electron of wavelength 1.66 into 10 power minus 10 meter. So whenever you are given a problem, first see what is the data which is given for you and note it down. And you should also identify what exactly you should be able to find out at the end. And try to relate the given data and the data to be found with the set of formula which you know. And pick the formula which is suitable for this given data and the data to be found. There you are. And just you can substitute. And if there is anything to evaluate from the formula, you can try to evaluate and conclude with the result. Let's move ahead with this problem. So what is given here? Lambda is given. Lambda is given as 1.66 into 10 power minus 10 meter. So what is it that you will have to find out? You will have to find out the velocity, and you should also find out the kinetic energy. So first let us go with the velocity with the given data. What is given? The lambda. So you can know from the de Broglie's wavelength formula, lambda is equal to h by mv. So from this you can calculate the velocity as h by lambda into m, right? H by lambda into m. So these are the values which you have to remember: the Planck's constant and the mass of the electron. And lambda is given for you. Just substitute all of those. 6.6 into 10 power minus 34 by lambda is 1.66 into 10 power minus 10 into m is 9.1 into 10 power minus 31. If you solve it out, you will get velocity in meter per second. So now if you hold on, proceeding ahead to the next entity which you have to find out, the kinetic energy. The kinetic energy is related to your given data lambda in terms of lambda is equal to h by, you have different forms of the de Broglie's wavelength, right? Lambda is equal to h by p, h by mv, 1.22 by root v nanometer, and h by under root of 2 mev, h by under root of 2 m capital E. So you can choose this formula, lambda is equal to h by under root of 2 me, where you will have to find out what is E. So how can you find out what is E? Lambda square is equal to h square by 2 me. So from this, E is equal to h square by 2m lambda square. You have h, you have m, you have lambda which is given. So from that you can find out E. Try to find out and try to relate with the formula which is given for you. You will end up in h, because it is in joules seconds. You will end up in the answer as joules, but try to represent it in the form of electron volt. And coming to the next problem, calculate the wavelength associated with an electron with energy 2000 electron volt. So what are you given here? Energy. Energy is given as 2000 electron volt. And what should you find out? Lambda is equal to how much? So the same formula again, lambda is equal to h by under root of 2m E. Okay, so now you have all this formulae, and h, because it is in joules, convert this electron volt using this relationship. If 1 electron volt is equal to 1.6 into 10 to the power of minus 19 joules, how much will be 2000 electron volt? Many students fall into problem when solving this type of conversions. Okay, just go for cross multiplication. Okay, this into this by this. Okay, so 2000 into, so this comes as 2000 into 1.6 into 10 power minus 19 joules by 1. So it will come as this result. Okay, so substitute energy, Planck's constant and the mass of the electron, and then you will end up in lambda value. So this should be your lambda. I have given it in nanometer. Please check it and you can respond in your comments with your answers also. Okay, you can even find it out in meters or whatever you find out, please respond. Next, third problem. An electron is moving under a potential field of 15 kilovolt. So volt's potential field is given as 15 kilovolt. 15 kilovolt means what? 15 into 10 power 3 volt. So you need to find out lambda. Lambda is equal to, what do you know? 1.22 by root V nanometer. Substitute this here. You will have to end up in this answer. The same way you are given the fourth problem. If 100 volt is given, just substitute root V as root 100. Okay, and you should end up in this answer. And if an electron moves under a potential field of 1.6 kilovolt, so V will be equal to 1.6 into 10 to the power of 3 volt, then the wavelength is lambda is equal to 1.22 by root of 1.6 into 10 to the power of 3. So these are the answers for you which are given in angstrom. Try to go for the right conversions and check with it and respond. Electrons are accelerated by 344 volts and are reflected from a crystal. So now you are trying to relate the de Broglie's hypothesis with the Bragg's formula. You know, Bragg takes a crystal lattice and incidents the X-rays and takes the reflection and studies how the constructive interference is related with the crystal lattice, that is the interplanar spacing and the glancing angle. Thus, he gave you a Bragg's equation which is n lambda is equal to 2d sine theta. So you will have to relate both of them here and find out the spacing. So what are given here? Are accelerated by 344 volts. So voltage is given as 344 volts under reflected from a crystal. The first reflection maxima. First reflection maxima means we know what is Bragg's law. N lambda is equal to 2d sine theta. This is the formula where n is the order of diffraction, lambda is the incident wavelength, d is the interplanar spacing and theta is the glancing angle. So n is equal to 1 and what else is given? Determine the spacing of the crystal. That's all. D you have to find out. But yes, if I substitute whatever is given in this problem, then let me see if I'll get any hint. 1 into lambda is equal to 2 into d also I don't know. So sine of 60. Okay, this I'll find. I'll try to end up in some value because I know trigonometry. But if I'll have to find out d, which is what I need. What is d now? Lambda is equal to 2. D is equal to lambda by 2 into sine 60. But I need lambda. In order to get lambda, I have some tool here where I can use my weapon of de Broglie formula. 1.22 by root V nanometer. Substitute in this, get the lambda, go for substitution here, then you will end up in D as this answer. Lambda should be 0.661 nanometer. So that's how you can do it very nicely. Let's go for the next problem. Calculate the energy of an electron in the energy level immediately after the lowest energy level confined in a potential well of width 0.1 nanometer. Now you are arriving at the potential well problems. If you can recollect the concept, there you have taken an electron in a potential well and you subject it to some conditions and we have ended up at the wave function as psi of n is equal to root of 2 by L sin n pi x by L. And you also could gather the probability by taking the square of it by psi square, which is the Born approximation. And if you are given any space, then you can multiply with that particular volume or finite space, and then you can get the probability of the existence of the electron in that particular space. And suppose, that's where you can find out. And the final derivation, you could end up in quantizing the energy values of the energy levels of the electron as it excites from one state to the another state, which is given by En is equal to n square h square by 8m L square. That's what the formula which you are using now. Okay, where n is the principal quantum number. As n increases or with different values of n, you will get different values of E. So that's what you are able to do it now. Calculate the energy of an electron in the energy level immediately after the lowest energy level. Immediately after the lowest energy level means what? If I'm taking a potential well and of width 0.1 nanometer, and this is the first level, n is equal to 1, then the next level will be n is equal to 2. So immediately after the lowest energy level means how much? N is equal to 2. This is what I want. So here an electron is existing, and that's what I have to calculate the energy of this electron. So we know that En is equal to n square h square by 8m L square, right? And you know what is h and what is m, and you know n as 2. So 4 into 6.6 into 10 to the power of minus 34 by 8 into 9.1 into 10 power minus 31 into L is given as 0.1 nanometer. So it will end up as, because this is kg, I have to convert it into meter, 10 to the power of minus 9 whole square. Solve it out and you'll get the answer. So this is the how you will have to understand which energy level is really needed here to solve and end up at the answer. If you take it, if you just miss understanding immediately after, and if you just think that, skip the words and think that it is lowest energy level and find it out for n is equal to 1. I have seen many students, they just solve it out very nicely, but they don't understand the problem and they end up at solving for some other energy level. Please don't do that. Try to read the problem properly and try to picturize it, and then understand the problem and solve it out. Now see the 8th problem. An electron is bound in a one-dimensional box of size 4 into 10 power minus 10 meter. It's given in meter. So L is given. What will be its minimum energy? Minimum energy means what? N is equal to 1. So you will have to find out E1. Calculate the first 3 permitted levels of an electron in a one-dimensional potential well of 1 angstrom wide. So L is given as 1 into 10 power minus 10 meter. So what should you find out? First 3 permitted levels. First 3 permitted levels means this is the first level, this is the second level, third level, N is equal to 3. So you should find out E1, E2 and E3. How should you find out? Should you find out for each and everything? Let me tell you. See that with this problem you will get a very good clarification. An electron is bound in one-dimensional infinite well of width. So there is a one-dimensional infinite well of width 1 into 10 power minus 10 meter. So L is given as 1 into 10 power minus 10 meter. Find the energy values in the ground state. So E1 is equal to how much? First 2 excited states. So suppose if an electron is there here, and if it's this is n for n is equal to 1. If it excites, where will it go? First excited state means what? N is equal to 2. And first 2, that means the second one also. The second excited state will be n is equal to 3. So many people will think that first 2 means n is equal to 1, E1 and E2. No. The electron is there in the lowest energy. Ground state will be for n is equal to 1. First excited state will be for n is equal to 2. Second excited state will be for n is equal to 3. So E1 is equal to how much? E2 is equal to how much? E3 is equal to how much? And this is the same. If you are asked for permitted levels, it will say first 3 permitted levels. First 3 permitted energy levels or 3 permitted energy levels. Okay. So that's what you will have to understand the problem now. Now, I'll tell you a relationship between the levels. En, what do you know? N square h square by 8m L square. This is a formula which you know very well. So for n is equal to 1, what will it be? E1 is equal to h square. 1 square means h square by 8m L square. And what will be for n is equal to 2? E2 is equal to h square by 8m L square. We are missing something here. What is that? 2 square means 4. And for n is equal to 3, E3 is equal to 9 h square by 8m L square. So if you observe here one thing, there is one thing in common for E2 and E3. What is it? H square by 8m L square. And it is equal to E1. So I can write E2 as 4 into E1 and E3 as 9 into E1 and so on. It will go on and on and on. So that means for En, so this is nothing but 2 square into E1. E2 is equal to 2 square. E3 is equal to 3 square. E4 is equal to 4 square times E1. Okay, so that means En is equal to n square times E1. This is your formula. Holding on to this formula, you can just calculate E1 and go for any number of excited states, just substituting it in this formula. Right? So, first calculate for En and using this constant values, and then take E1, substitute this formula, you can get E2, and in this if you substitute, you can get E3. Okay, and these are the values. Please convert them from joules to electron volts. Okay, that's how you will end up in this problem. The next problem. A quantum particle confined to a one-dimensional potential box of width A is known to be in its first excited state. Determine the probability of the particle in its central half. As I have told you, we know that psi n is equal to under root of, what do you know? You know psi n is equal to under root of 2 by L into sine of n pi x by L. So the probability, how will you get? Mod of psi n square is equal to 2 by L times sine n pi x by L. If you are given any finite volume, then you can multiply it. Okay, so now coming to this particular problem, it's very easy to understand. That is, you want Pn, which is psi n square. So 2 by L sine square of n pi x by L is the formula. So where is it asked? There is a potential box, one-dimensional potential box of width A to be in its first excited state. First excited state means if it is n is equal to 1 and then this is n is equal to 2. So the electron is here. Determine the probability of finding the particle in its central half. Central half means it's here. Okay, that means A by 2. Okay, so here you can get it as, substitute it as L by 2. That is, you can also write it as A by 2 is equal to 2 by L into sine square of, what is n is equal to? The order is 2. So n is equal to 2 pi. Where should you find out? X is what? L by 2. So L by 2 by L. Keep the L as it is. So what do you end up in? Sine square pi. You know sine square pi is equal to 0. Anything multiplied by it will be 0. So what is the conclusion here? There is an absence of the particle at the central half of this particular box of width A when the electron is excited to the first excited state. Okay, that's the conclusion which you have to write. Don't just end up in calculating this, but you have to write the conclusion. So there is no existence of electron in the first excited state of potential well. Okay, this is how you have to write. A particle is moving in one-dimensional box of width 10 angstrom. Calculate the probability of finding the particle within an interval of 1 angstrom. So there is a potential box of width 10 angstrom. Calculate the probability of finding the particle within an interval. Within an interval means you are given now in a infinite space. You can predict it as if like you are given x, in x you are given dx. So you are given it 1 angstrom. Maybe I can take it here, but let me represent it as 1 angstrom because till now you have taken it, or else I'll take it somewhere here. 1 angstrom. Why should not I follow the scale? Okay, at the center of the box, within an interval of 1 angstrom, at the center of the box, this is continuation, okay, this is continuation. At the center of the box, when it is in the least state of energy, at the center of the box. So, within 1 angstrom width, it is at the center of the box. So, that's the reason why I can take it as, let me repeat once again. I'll take a one-dimensional box of width 10 angstrom and calculate the probability of finding the particle within an interval of 1 angstrom at the center of box. Okay, so when it is in the least state of energy means n is equal to 1. So we know the function sin of x is equal to under root of 2 by L times sin of n pi x by L. So if I substitute the given conditions, what is it? Under root of 2 by L sin n is equal to what? N is given as 1. So 1 into pi into x is what? At the center of the box. So L by 2 of L. So you will be left over with what? Sin pi by 2. So L and L gets cancelled. So you will be left over with sin pi by 2 is what? 90. So you are left over with sin 90 is 1. So it is root 2 by L. But what do I need? I need the probability. Probability means what? So Pn of x is equal to mod sin of x square dx. So dx is what? In x you are getting dx. In 10 angstrom now you have 1 angstrom. But what is x for you now? X is under root of 2 by L. Okay, square, okay, dx. So dx is what now? 1 angstrom. 1 angstrom means what? 1 into 10 to the power of minus 10. Why don't I take L also as 10 angstrom here? So 2 by 10 into 10 power minus 10 into 1 into 10 power minus 10. So this and this gets cancelled, you result in 0.2. So there is 0.2 times the probability of finding the particle within an interval of 1 angstrom at the center of the box when it is in the least energy state. Okay, this is how you have to conclude. Going to the next problem, an X-ray tube is operated at 18 kilovolt. X-ray tube is operated at 18 kilovolt. So V is given as 18 kilovolt. So that is equal to 18 into 10 to the power of 3 volt. Calculate the minimum velocity of the electron bombarding at anti-cathode. So you will have to calculate the minimum velocity. So once X-rays are falling on the electron, it is being bombarded with the electron and then it moves and gains the kinetic energy. So the energy of the electron is half m, what it is? Kinetic energy half mv square. But how can I get? I don't have any support here. But if I have to take the support from the given information which is in volts, I have to connect this energy to some formula which can give me relationship with volts. What is it? If an electron of charge E is subjected to any potential V, then this is the energy. So if this is minimum velocity, so from this I can find out V minimum square is equal to 2 EV by M. So V minima will be equal to 2 EV by M. So you can just use this M here, and you know the charge of the electron V is given, and then you will end up in the minimum velocity of the electron. Electrons are accelerated by 344 volts and are reflected from a crystal. So again here you are given V is equal to 344 volts. Okay, and are reflected from a crystal. The first reflection maxima, right, n is equal to 1, occurs when glancing angle is 60 degrees. So theta is equal to how much? 60 degrees. Determine the spacing of the crystal. Now what do you know? You know from the Bragg's law, n lambda is equal to 2d sine theta. You are given 1, you don't know lambda, and 2, this is what you have to find out, sine 60 degrees. So lambda you can find out by lambda is equal to 1.22 by root V nanometer. Whatever the answer you get, you substitute here, and then you can find out D. This is similar to the problems which we have done previously. Calculate the de Broglie's wavelength of neutron whose kinetic energy is 2 times the rest mass of electron. It's a very simple problem, but here they have related the neutron's properties with the electron's physical property. We can do it very nicely. Just follow me, because you are given everything. The mass of the neutron is given, mass of the electron is given, velocity of light is given, and the Planck's constant is given. So what is it that you have to find out? Lambda of the neutron is equal to how much, and whose kinetic energy? Kinetic energy of the neutron is equal to how many times? 2 times the mass of the electron. So what will be the kinetic energy of the neutron? We know very well, half mv square of the neutron is equal to 2 times the mass of the electron. How can I write in terms of momentum? Can I write half mv square in terms of momentum? Yes, it is p square by 2m, because kinetic energy is half mv square, and if you multiply and divide with m, I can write it as m square v square by m. And since p is equal to the momentum, p is equal to m times v, I can write it as p square by 2m. Sorry, 2m. So taking this, m of what? M of the neutron is equal to 2 times the mass of the electron. So from this, p square is equal to 4 times mass of the neutron times the mass of the electron. So from this I can write p as square root of 4 mn me. Okay, so now I have p and I need lambda. You know very well, lambda is equal to h by p, that is equal to h by under root of 4 mn me. You are given h, you are given mn, yes, you are given mn, you are given me. Just substitute and you will end up in the answer as 8488 nanometer. Hope you all have followed me in solving the problems. You can just practice by picking some more problems from your regular classwork or your textbook, and practice well, and do often revise the formula so that you will not feel confused with the rest of the formulas you will be learning from the next modules. And in my next video lecture, we will be starting module 2. Hope I'll see you back in my next video lecture. Wishing you all the best. Bye.
Like, share and subscribe. Hit the bell icon for more updates.